Hi, and welcome back. Last time we talked about the alternate numbers, but in this episode, we're going to be using this image of the Pascal Triangle numbers in hexagons to show our next trick. First, what we're going to do is that we're going to pick something to be the grand prize, and that's going to be, let's say, 3. 3 is going to be the grand prize. And all the numbers around it are going to be the special numbers that you use in this trick. So let's observe these numbers. We have the grand prize 3. We have a 1 and a 3 to either side. We have a 1 and a 2 above, and a 4 and a 6 below. Because we used alternate stuff last time, let's try to use alternate stuff again this time. So what I'm going to do is that I'm going to just pick the alternate numbers in like a zigzag pattern, meaning that I'm going to take this first one, the other number is this one, so I'm not going to pick the first one, but I'm going to pick like the first, last, first, and the last, first, last. So that's group 1. And group 2 is like this. So let's look at the numbers. This is group 1, and this is group 2. What do we see that is in common in these numbers? Well, it seems like if we add them, if we just simply add these numbers, then we get 9. And if we add these numbers, we get 8. So it doesn't seem like there's anything special there. But what if we multiply? If we multiply, we get 12. And we also get 12. Does this happen for all these zigzag pattern numbers? Let's see. Let's take a look at another example. Let's say I picked the 4 right here. That means I picked the numbers around it. So 3 are above the 6. The 4 and the 4 are on either side. And 10 and 10 are below. And this one's a little more obvious. You have 3 in this group times the 4 times the 10 is equal to the 3 times the 4 times the 10. And so what's going on? How is this so perfect? Let's see whether we can try to prove this. What I'm going to do is that I'm going to use the combinations trick that we had earlier. So I'm just going to say that the middle number here is and choose R. That's the grand prize that we've been looking at. And that means that there's 6 numbers, 2 on the top, 2 beside, and 2 on the bottom. So on the top here, we have n minus 1. Choose R. Minus 1. Right? Because remember, the sum of these two, and choose R plus and choose R plus 1, is actually equal to n plus 1, R plus 1, right? So that's going to be R minus 1. And then this one here is going to be n minus 1, choose R. And then this one right here is just this number, so it's going to be in the same row, and it's going to have the R minus 1. And here, it's on this side of it, so it's going to be n. It's going to be r plus 1, because if this is r, then minus 1 is going to be r minus 1, and then this way it's going to be r plus 1. Okay, now below is going to be the n plus 1. In the sum of this number, this number plus this number, it's going to have the same r. It's going to have an r here, right? And then this one is going to be one number in front. So it's going to be n plus 1, r plus 1. So now that we've found out all the terms in terms, of the middle number, let's see what we get. Well, this number, and this number, we're going to call that the blue group. And we're going to have this number, and this number here. That's going to be the orange group. So we're going to say that in the blue group, n minus 1 choose r times n over r minus 1 times n plus 1 r plus 1. And then we have the orange group with the n minus 1 r minus 1 times n r plus 1 and times the n plus 1 choose r. So we see, if you look, we have the n minus 1, n minus 1, n plus 1, n plus 1. And remember, if we expand these combinations out, you're just going to get the factorial of these, so they're still going to be the same. Then you have the r and an r minus 1, and r minus 1, and an r plus 1, and an r plus 1. And remember, if you expand, it's just going to be r times this top minus 1, but it's going to be the same. You can expand it and see for yourself. So I hope that you found this cool, and see you soon. Bye.